we're working on adding this rational expression. And these right here are both fractions, and if we remember our rules of fractions, they have to have the common denominator in order to add or subtract them. So if we look at this one, this has an n plus 4 as our denominator, and this one here has an n plus 5. So if we think of our normal rules for fractions, if I had 1/2 and I wanted to add 1/3, these two do not have the same denominator. But what we can do is find the lowest common denominator. Now, the lowest common denominator, in some cases, we just end up multiplying these two. So this one I would multiply top and bottom by 3, and this side I'd multiply top and bottom by 2, so whatever this other one is. And so we're going to use that same logic, if you will, on this problem here. We're going to multiply this side, top and bottom, by n plus 5. And then this one over here, we're going to multiply top and bottom by n plus 4. So let's work on that now. So I've got 6 over n plus 4, okay, and we're going to multiply top and bottom by n plus 5. This is the quantity, n plus 5. And where I got that is just this one. That's what this side is missing. If I multiply top and bottom by that n plus 5, I forgot my parentheses, sorry, that would give me what I'm looking for there. So on this one, on this particular one over here, I'm going to multiply top and bottom by n plus 4. So let's do that. This is plus 3 over n plus 5, and I'm going to just put parentheses around it. Now remember, when we're looking at this one, it's the same thing as if it were a parentheses there. That's what the meaning of that one is. So again, I'm going to multiply that top and bottom by the other side, which was n plus 4. Top and bottom, that way I do not change its value. Okay, now we're going to distribute here 6 times n and 6 times n plus 5. So 6 times n gives me 6n plus 30. And then this is n plus 4 times n plus 5. Plus, and right here, we've got 3 times n would give me 3n. 3 times 4 would give me 12. All over n plus 4 times n plus 5. Well, let's see if we can't write that 5 just a little bit neater. Okay, now notice on these two I switched the order. Up here it was n plus 5 times n plus 4. Again, the order doesn't matter. With multiplication it can be in any order. It doesn't matter as long as they're multiplied by each other. So we're okay there. So now I have to look here. Now these have the same denominator. So I am going to just add the numerator up top here. Okay, so this is the same thing here as 6n plus 30 plus 3n plus 12 all over n plus 4 times n plus 5. Okay, now I have to go through here and I see that I've got an n here. I can combine this one with that one. And then I can also combine this 30 is just a number, and so is the 12, so I can combine those two. So I'm going to do that now. 6n plus 3n gives me 9n. 9n. And then 30 plus 12 would give me 42. Plus 42. All over n plus 4 times n plus 5. And that one is my answer. I can't reduce that one anymore, and you want to always kind of think about it. You look here, 9n plus 42, 9 doesn't go into both of those. I could do a 3 would come out of that, but that would give me 3n plus 14. That wouldn't really help, it wouldn't reduce it at all, but I could take that if you wanted to write that as your answer, that would be okay. You could write that, it would look something like this. 9, whoops. 3 times 3n plus 14 all over n plus 4 times n plus 5. I'll take either one of those. For clarity purposes, I think this one's a little bit clearer. But these two are equivalent, so that would work too. I'm okay with that.